All right. All right. Good morning, everyone. Thanks for joining. So my name is Martin, and I work in DICE, the Dublin Institute for Advanced Studies. So just before I start talking about the fin whales, I just want to mention what DICE actually, the slide doesn't, next turn. What DICE actually is. So DICE is a government-funded research institution, so it's not a university. It's a research institute, and it was founded 1940 by Eamon de Valera. And we have three schools: the School of Theoretical Physics, the School of Cosmic Physics, and the School of Celtic Studies. The School of Cosmic Physics has two sections, the Astronomy and Astrophysics section, and the Geophysics section, and that's where I work. So we study anything that has to do with the planet and use physical methods to do that. So we do a lot of volcano work, we study earthquakes and the structure of the Earth. The different methods you can use in geophysics, for example, gravity, magnetic field, and seismology. So seismology mainly uses shock waves that come from big earthquakes, and you study those to find out more about the Earth. So that's a big focus in DICE in the geophysics section, and that's also where I work in. So I will now in the talk try to explain to you what the link is to the fin whales. So, but first of all, what are fin whales? So if you look at this chart of the whales of the world, you can see there are two types of whales really. On the left, we have the baleen whales, and on the right side, we have the toothed whales. So all the whales in that picture that are facing to the left, they have teeth. They're toothed whales, like you can see in the skeleton here to the right. So these whales are hunting other animals like seals and so on. And by the way, the smaller animals here, they're all dolphins, but technically they're cetaceans as well, whales. But we don't call them whales. Any whale that is smaller than 3 or 4 meters, uh, we wouldn't call it a whale in general. But then the larger whales, you have here the orca, and then at the top, the sperm whale. On the left, you see these baleen whales. So baleen whales, they don't have teeth. They have these plates kind of, you can see in the skeleton here on the right. It's like big brushes. So that's quite different. They don't really hunt larger animals. They gulp huge amounts of water, filter it out for small animals, krill and small fish. And you can see on the top, that's a blue whale. That's the largest animal on the planet that ever lived on the planet. And just underneath the second one here, the second largest animal on the planet, they are the fin whales. Both these whales, the blue and the fin whale, exist in Irish waters. The blue whale doesn't really come close to the coast in Ireland, but the fin whale actually does. And further down here, you see the right whales that were mentioned. And then in the middle, that's a humpback whale that was also featured in the movie. And most of the sounds and songs that we heard in the movie were from the humpback whale. But why are we interested into the fin whale? But before I go over to the next slide, I wanted to show you how the feeding looks for the baleen whales. So when they got these huge amounts of water to filter for small fish, it's called lunch feeding. And I found on TikTok, on internet, a small video from a drone operator who filmed fin whales off the waterfall called. Up to 25 meters. This was very close to amazing video. So why why are people interested in recording whale song? I think it became clear in the movie there. It's the main source of information we have about whales. It's their main way of communicating to each other, of finding food, and so on. In water, you can't see very far. You know that from when you dive, and it's the same for the whales. They have eyes, but they really you can't see very far. But by communicating in the water, they can communicate over very large distances. Uh, like acoustic waves travel much further in water than in air, so that's important to know. So it's the main way to study whales is to record them using hydrophones. So the sounds in the movie there that we saw earlier, they were recorded with hydrophones. So hydrophones basically, it's a microphone that works underwater. In this sketch, you can see how scientists do this. So they use a buoy and then they suspend hydrophones and a recorder underneath on a rope, and then they record these sounds. But we don't do this in geophysics. We work with the solid Earth, so we use seismometers. And here you can see a sketch of an ocean bottom seismometer. So there are seismometers that can not only be used on land, but actually you can sink them in the sea, deploy them on the sea floor. So seismometers always need coupling to the solid Earth. So these instruments would sit on the sea floor. Looks like a complicated sketch, but really it's just batteries, a data recorder. There at the bottom it says geophone. That's the same like a seismometer. And then here at top you see there's also a hydrophone. So the ocean bottom seismometers we use, they also have hydrophones. So usually seismologists, geophysicists, they deploy these not to record whales, but to record seismic waves coming from earthquakes, etc., to study the solid Earth. But again and again, people see all these whale signals in the data as well, and it's quite interesting. And there are a lot of studies from ocean bottom seismometer data about whale recordings. And the interesting thing is that these whale calls and whale songs, they're not only recorded in the hydrophone, but just as well in the seismometer. So if actually, I think I have a small movie here where we can see at DIAS, the Dublin Institute for Advanced Studies, we have a pool of 17, 18 of these OBS. They're very expensive instruments. You see the start screen here. You can see how this was deployed 3 years ago. We had an expedition in the Atlantic offshore Ireland. The black thing there, that's a hydrophone. And the silver thing, it's a cylinder and it contains batteries. So the instrument gets suspended and once it's in the water, it gets released and then it sinks down to the ocean floor. It takes about 15-20 minutes if it's deep water, like this can operate because 3,000 meters deep. And then a year later you come back, give it a signal, and it will get released and then come up back to the surface, is collected, and we look at the data. So in this sketch, you can see if now one of these OBSs, as we call them, sits on the ocean floor and a whale passes by and is singing, then this will be recorded on the hydrophone, but as well on the seismometer. And here in the sketch from a publication from people in Canada, you can see that then these seismic waves in the underground. So a seismic wave is basically a shock wave that does go through the solid Earth rather than the water. And P-Lord here, these people, this research team, they found that sometimes these seismic waves can be detected even on seismometer that's on land. So we thought that's interesting. We're on an island here. Maybe we can see it in our data. And we did, as you will see later in this talk. But how is it possible that you can record something on land from an animal in the water? It's pretty amazing. Well, the reason is that the song of the fin whales and blue whales, by the way, as well, is extremely loud. It's equivalent to 130 dB, so that's much louder than in a disco. It's more on the level of a jet engine, and it's actually close to the threshold of pain for humans. It's very, very loud. So that's the reason why this is possible. Well, it's one reason why it's possible. How can these animals make such loud noises? Well, the main reason really is that they're very large. As you've seen in the video, you could see the scale to dolphins. They're very long. They get up to 23, 25 meters. I've, in the sketch, put in a comparison to buses. So it's twice the length of a large bus. And they weigh up to 80 tons, which is equivalent to 6 double-decker buses. So they're very big animals, and that's why they can create these really loud sounds. The other reason we can pick up these signals on land is that in Ireland, they come really close to the coast, the fin whales. The blue whales don't. They stay in the deep water. So on this sketch, you can see here the bathymetry. So around Ireland, the darker the blue, the deeper the water. So the blue whales, they would stay out there. But you can see the yellow dots. Each yellow dot is a sighting that was reported from the Irish Whale and Dolphin Group. So they collect sightings from people that see fin whales on boats, but also from land. And there's, so what I plotted here is all the sightings from 2005 to last year or to 23. And they come particularly at the south coast and southwest coast, Kerry and then Cork up to Waterford. They come pretty close to the coast often, and you can sometimes just see them from a headland, which is amazing. And I didn't know actually before I looked into all this. The black triangles here on onshore, they're the permanent seismometers we operate in the Irish National Seismic Network. So we operate that here in Dyes to look for earthquakes and other signals. Most of the stations aren't very close to the coast, but some are, like here in Kerry and then here in Waterford. So we had a look at the data and could indeed find some fin whale calls in our land data. Yeah, I just wanted to show you this sketch, which is showing you the sightings from last year, 24, whereas on the left, it's only up to 23. And there's one interesting change that happened last year that suddenly there were fin whales spotted quite a bit in October in Donegal Bay, whereas on the left figure, you can see that there are only 2 sightings within nearly 20 years. So they usually wouldn't have gone into Donegal Bay, so there must have been some change. That they got interested to go there, and surely it's because they just go where the food is really, where they can find fish. So, and there was also one sighting, by the way, in Rathlin Island, which never happened before. So yeah, this is quite interesting, and I want to show you now these 3 triangles here. They're examples of seismic stations that we operate not as part of the permanent national seismic network, but of QuakeShake. QuakeShake is a citizen outreach program we operate since about 2 years now. So where we try to get schools and citizens interested into operating lower budget citizen science seismometers. There are many more around Ireland. I have a plot of that later on. I just wanted to show you here in Waterford that this one, which operates in the geopark there, detected fin whale calls. And then these 2 were installed after the fact last year that fin whales were seen in Donegal Bay, and one of them is operated by the Green Schools team. Okay, so what does the recorded sound actually look like and sound like? I hope you can hear this. So what we have here is on the bottom, this is a seismogram. So this is from a seismometer at IBMH, is a station call code. It's in Banmahan, and not that far from Helvig Head. And basically, the seismogram here just shows how strongly the ground moves up and down. And it literally moves up and down because there must have been a fin whale call very close to the coast and singing. The song, as you can hear, is quite different to what we heard in the movie. In the movie, it was mainly humpback whales, whereas fin whales, they have these notes that are around 20 hertz. So the upper colored part here, that's a spectrogram. And you can see that these vertical bars are around 20 hertz. And that's on the hearing limit of humans. So normally you can't hear low frequencies lower than 20 hertz. So this is right on the limit what humans can hear. But here I play back this movie 10 times faster than it actually was recorded. So in reality, each note would be longer, about a second, and between each note there would be 10, 20 seconds rather than only, say, 2 seconds here. Here at the end of the plot, I put in this black rectangle there, and the vertical signal here, the larger signal, that's actually an earthquake. So I will zoom in of this in the next plot, in the next slide. And the stronger signal is actually an earthquake, a very small earthquake, magnitude 0.1, so that's tiny, that happened close by to the station in Waterford. And what I find interesting, so the recording, by the way, was made here 25th December, so Christmas Day in the morning, just after 7:30. And I find quite interesting the whales singing along here, the notes, you have like 3 notes, and then you have this smaller so-called backbeat. And it doesn't seem to be disturbed by the earthquake, but from the color and the amplitudes here in the seismogram, you can see that the whale for sure heard this. It's on the same strength of the sound that the whale was making. How do we know that this is an earthquake here, this stuff? Well, as I told you, we operate the National Seismic Network, and here are the stations on the map. And we recorded on 4 stations the signal, and you can see here in the seismograms, the first one is from the Waterford station, the second one from Mitchellstown Cave, and then there's the one in Wexford. We just about picked it up at DSB, which is a station we have in Dublin. And you can see how the signal arrives later and later because the seismic waves need time to go from the epicenter there, the red star, to each station. And because of these time differences, we are able to triangulate where the earthquake was. And the amplitude helps us to calculate the magnitude, which was very small, 0.1, as I just mentioned. Uh, and by the way, I just wanted to show that there are actually earthquakes in Ireland. So that was an earthquake, and there's sometimes somewhat stronger earthquakes onshore up to magnitude 2.5, offshore sometimes 4. So really on the global scale, that's not very large. It's fortunately not damaging, which is good. But especially in Donegal, but also sometimes on the south coast and the southeast coast, people report to us that they felt earthquakes. But it's rare enough. So on this map, I show you some other stations where we, on the south coast, where we detected fin whale calls. So here in Baltimore and then near Galley Head, this UGAL 4 station actually used to operate. We don't operate at the moment anymore. In the Galley Head, sorry, lighthouse. And this data I showed you there was from IBMH. And this pink triangle there marks the location of a QuakeShake station that we operate there together with the Copper Coast Geopark. So the station operates, you can go and have a look there in their visitor center. And these stations, they're low budget, as I mentioned. They're called Raspberry Shakes because they're based on a Raspberry Pi on a small computer, and then there's the geophone. And in our project, we try to motivate people to buy these, in schools and citizens. But we also have some units that we sometimes raffle out. Or last October, we had a workshop and handed out units to people in Donegal because, as you've seen in the previous plot, it's a bit of a hotspot for earthquakes in Ireland. And there are now like 15, bit more than 15 stations operating up there. So QuakeShake is, just to summarize what QuakeShake is for you, is an outreach program operated by us in DICE. The outreach officer is Laura Riley. She's on the call here as well, actually. And we got funding as well from Geological Survey and Research Ireland. We use these Raspberry Shakes, as they are called. And the whole idea is to get as many people as possible involved and interested into science and into seismology. And we mainly support people online to operate these units. So back to the fin wells, and this is nearly my last slide. I think it's my second last slide. So, and how far can this be useful? This fact that we discover we can sometimes record fin wells from land. Well, maybe we can contribute to the science of understanding fin whale behavior. And there's actually not that much known about fin whales, even they're such large animals, but the ocean is so big, and it's much harder to monitor things than on land because it's difficult to have power. And how do you send the data back to your base from the open ocean? It's very difficult. So even the number of fin whales is poorly known. How they move and migrate is also not very well known. Other whales, for some, it's known that they have breeding grounds and so on. For the fin whales, it's not really clear where these breeding grounds are, or maybe it seems maybe there aren't, and they just use different areas. And it's very difficult, it turns out, to tag fin whales because they're very fast swimmers, and tags usually don't last very long. And maybe the different songs recorded. So I didn't really mention that in different regions of the planet, it has been found that the songs that they sing are slightly different, so they can have different frequencies, and the intervals between the individual notes can be different and so on. So this can be possibly used to differentiate different populations. Also, how they actually produce the sound and how they can hear is very poorly understood. Not much is known about it. And then finally, because as mentioned in the movie, there's more and more ship traffic, and it uses a lot of noise into the ocean. And there are also ship strikes. So sometimes whales get injured because all the whales are mammals and they have to get up to the surface every 10 minutes, say, to breathe. So sometimes they get injured by boats or they get entangled in fishing gear. And the noise pollution can, of course, impact their communication. And climate change could have an impact on them as well. So these ship strikes, entanglement in fishing gear, and noise pollution are especially significant near the coast. So I've made a plot, or I downloaded this plot here marine traffic around Ireland in 23. And you can see that, of course, there's especially a lot of traffic around the coast. So the method to record the wells from land is, of course, limited to wells that are pretty close to the coast. It doesn't really work if they're too far out. Then you need hydrophones. But it's far easier to operate equipment on the coast and transmit the data through the internet. So it could be quite useful maybe to help with the threats that the fin whales face when they come to the coast here in Ireland to feed. So maybe when we detect the whales, for example, maybe one could request that the marine traffic has to slow down to make less noise, etc. That could be maybe something there. So I leave it at that. And of course, I'm available for questions. And on the last slide, I have the couple of links if you're interested. So you have the QR code there and the web addresses of QuakeShake, the National Seismic Network. If you go there, you can see the last earthquakes, and also we record a lot of all the quarry blasts around Ireland, and we also record distant earthquakes, of course, in Ireland. So you can find more information about that. And then there's my email address and our home link to Dice Geophysics. Thank you.